Assalamualaikum and a very good evening. So my name is Iskandar bin Sabri and I am from Group 7. So today I will be presenting about the methodology of our assignment, which is our project. So our project is to detect the broccoli and get the data set, and then data set have to export to the Google Colab, which is we need to get the result for three epochs, which is 5, 10, and 20. So before we export to the Google Colab, this is what we're gonna do. We have to detect minimum 200 of broccoli. Sorry, pictures of broccoli. So this is the data set that we get from the website, from the iStock website. We have to detect everything that include the broccoli. So we have 228 picture. So before we want to run the Google Colab, we have to export the data set, and then after we export data set, we need to create the Google Drive. So we need to create the folder on Project Chow, and then create the folder for Broccoli Detector, and then create the data. So from the image folder, we have to create two folder, which is validation and training. So validation and training, we have to put the original picture before we using the CBAT. This is what we're gonna do. For the label, we have to export the data set first in the CBAT, and then after complete the export, we have to put it into the file and trend under the labels folder. So after we do that, we have to run the Google Colab section, which is Trend YOLO 8 and Google Colab. Before we don't want to run, we have to make sure the coding on the Google Colab config and Trend YOLO. We have to create on our drive. So this is our Google Colab session on my drive, which is Broccoli Detector. So before we want to put the epoch on the VIP store Ultra Analytics, we have to mount the drive first, because we want to get the content and the result for our Google Drive. So we have to mount first. So we mount, we have to run the root direction, which is where we want to get the result, where we want to get the result on what folder. So I choose on Broccoli Detector folder. So after successful run the root direction, this we have to change this one. This one we have to change to 5, 10, and 20 for the result. for the three result that we've mentioned before. We have to run everything first, make sure it is successfully. The import OS, which is we use the model YOLO. Then we have to import the locale. If we not import the locale, we are not gonna get the content on SCPR. We get the error, so we have to add another coding, which is import locale. So after we change the import to 5, 10, and 20, we have to run this SCPR because we want to get the result. We want to get the content, the result, and the graph. After successfully run the SCPR content, we have to go to our drive on project child folder. We have to go to run. We have to go to detect. So this is what we get. This is what we get on changing the imports. So the first one, so this is on import 5. So this is result for import 5. And this is result for posting. Last one is posting. This is the graph, the label. So that's it. Thank you so much. I will pass to my friend to continue to present about result analysis.
And now, for the result of the project, the first result is the epoch 5. This is the draft result that we get. Now, talk about the result that we obtained for the epoch 5. Okay, this epoch is the epoch model that still learning, and the underlying patterns in the dataset, which is the precision may be lower because of the model prediction have not been yet fine-tuned. Okay, the loss may also be high because the model prediction are far off from the actual values, indicating that it is still learning. Next is the epoch 10. This is the draft result. Okay, when the result that we obtain, the epoch 10 is a model that the in a progress, the training is still in progress. The model begins to refine its parameters and prediction. The pressure may also increase as the model improves accurately identifying positive instances. And the loss that also may decrease compared to the previous epochs as the model prediction had become more accurate. Okay, for the last epoch is epoch 20. This is the draft result that we did, which is, as you can see, it's more fine-tuned from the previous epoch. Okay, where epoch 20, the model improved its precision and reduced loss as it learned from the data. Okay. However, overfitting the risk increases, impacting its ability to generalize to new data. Choosing the best epoch requires balancing position, loss minimization, and also generalization capability. Okay, that's all for the result.
So for the analysis, we have compared the three types of epochs, which is 5, 10, and 20. We have comparison three type of it, which is training loss, validation loss, and precision. So as you can see, the epoch 20 is better than the both of them because it has a better precision and fewer losses. So this makes it the standout epoch for its optimal performance. It identifying patterns accurately with low error rates. So when we're using the YOLO apps, we can find these categories, which is the first one is correct detection. So the YOLO can detect or locates the broccoli image accurately. So the second one is misdetection. It happens when we open the objects and it can be detected. So the third one is the mistake. It happens when the algorithm wrongly detects an object. So it's incorrect. But for the fourth one, which is precision, so it measures the accuracy of the algorithm, positive prediction. So when using YOLO, it gauges how well the algorithm detects broccoli while minimizing errors. So the last one is loss, which is it quantifies the gap between expected and actual outputs in machine learning. But for the fourth one, which is precision, so it measures the accuracy of the algorithm, positive prediction. So when using YOLO, it gauges how well the algorithm detects broccoli while minimizing errors. So the last one is loss, which is it quantifies the gap between expected and actual outputs in machine learning.